Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 293. Please turn to it. Page 293, problem number 4.6.2. And today is our lesson number 249. If you happen to have first edition of the book, revised GRE first edition, don't fret, don't worry about it. It's the exact same problem on the exact same page. Just turn to page number 293 and you will find the exact same problem. You understand? Let's get going. This, by the way, also happens to be the same problem as the one that appeared on page 79 of the 10th edition. If you happen to have, I don't know why you would have such an old book, and well, actually there is a good reason for it, I'll tell you in a second. If you happen to have this book with you, the 10th edition, the old GRE, in this book on page 79 you will see the exact same problem that we are about to do, which is 4.6.3. This book that I'm holding in my hand, the 10th edition, is actually an excellent source if you're interested in getting some extra practice on the quantitative comparison question. This book contains 7 exams. Each exam has 30 quantitative comparison questions, altogether 210 of them, and I have solved every single one of them. You will find those 210 quantitative comparison questions on my channel. Just look for them. Look for 10th edition quantitative comparison. 2.6.2, we are given a pie chart here, and the very first question says approximately what was the ratio of the sanitized goods. Okay, so we're looking for the ratio of the value of sanitized, oh for Christ's sake, sanitized goods to the value of still picture equipment in 1971. Let's find out, shall we? In 1971. So if we look at our chart there, we see the sanitized goods, we are told, is 47%. It is 47% of the total amount, which is 3980, and the value of the still picture, we are told, is 12%. It is 12% again of the same amount, 3980. Of course it is the same amount because it's coming from the same pie chart, and because it's the same amount, it plays no role. So basically we're looking for the ratio of 47 to 12. Ratio of 47 to 12 is approximately same as 48 over 12, which is 4. The ratio is 1 to 4. That's all. Ratio is, rather 4 to 1, not 1 to 4. Ratio is 4 to 1 because sanitized goods are 4 times the amount of the still good picture. So ratio is 4 to 1. Part B. In part B says they say, if the value of the copier produced in 1971 was 30% greater than the corresponding value in 1970, what was the value of the copier produced in 1970? Alright, let's find out. So we know that value of copiers in 1971 was, if you look at the chart of office copiers, actually, let me first write down the questions first. Value of the copiers in 1971, actually, question is, was, we are told, was 30% greater than the value of copiers in 1970. The question is, what was the value in 1970? And of course the chart that we have in front of us pertains to 1971. So we know now that in 1971 we are told, if you look at the graph, we are told it is 25% of 3980. It's 29% or 25% rather of 3980. And again, learn to approximate. Don't sit there and try to figure out the exact precise calculation. Nobody's going to give you extra credit for it. You understand? You must learn to employ your time wisely. So let's pretend it is 25% of 4,000, which makes our life far more easy to deal with, because 1/4 of 4,000 is 1,000. And the question simply now is, and the question now boils down to is, this is the amount in 1971, and the question now is, 1,000 is 130% of what? That's what the question boils down to. Because we are told that it was 30% greater. This amount we are told, this 1,000 we are told, is 30% greater than the amount in 71. We are told that the amount in 1970. So this is the amount we found for 1971, which is 1/4 of the total amount, and the total amount we see there is approximately $4,000. 1/4 of $4,000 can be $1,000, and that $1,000 we are told actually is 30% larger than the amount in the previous year in 1970. So we have to figure out what that amount is. You see, it is 30% larger than the value of the copiers in 1970. So let's find this out. This is all we have to solve here. The question simply is now, the question simply boils down to 1,000 is 130% of what? So let's find out, shall we? I'm going to do it on the top so we have the room. I'm going to do it on the top. So 1,000 is means equal, 130% means over 100, of means times, and our what is our unknown. So that's our equation. 1,000 equals 130 over 100 times x. Let's multiply both sides by 100 and divide by 130, or better yet, divide top and bottom by 10. So 1,000 times 10, so x equals 1,000 times 10 over 13. 1,000 times 10 over 13. How can we take care of it? Let's find out, shall we? Let's find out, shall we? 1,000 times 10, of course, is 10,000. So it's 10,000 over 13 is what we're trying to figure out. Let's do it here. Now, here's how it's going to go. Okay, pay attention. Learn to do things without the calculator if you can help it. We know 10 times 130 is 10 times 13. We know is going to be 130. Okay, pay attention. 10 times 13 we know is 130, and therefore half of that is 65. That I do know. That I do know. So 65 represents 5 times 13. Let's add one more 13 to it, so that gives us 8 and 78. I'm trying to get close to 100. That represents 6 times. That represents 6 times 13. Let's add one more 13, and we get 11 and 9. There we go. That's 7 times 13. So let's do it here. I'm going to erase all of this thing, or I'll put it a little bit lower here so we have more room. Okay, here's how it goes. Pay attention. Here's how it goes. How many 13 in 1? How many 13s in 1? 1 has no 13. That one goes and joins this guy, becomes 10. How many 13 in 10? How many 13s in 10? 10 has no 13s. That 10 goes and joins this guy, becomes 100. And that's what we're asking ourselves. How many 13s in 100? How many 13s in 100? We just found out that there are 7 times 13 is 91. So we can put down 7 here and get rid of this 100. So that's only 91. The remaining 9 goes and joins the 0, becomes 90. How many 13s in 90? We just found out. 90 has about 7 13. So there you go. This drops out, and that's 7, and that's 0. How many 13s in a 0? The answer is 0. So there is your answer. 770. 770. That's all. That's all there was. 770 is the answer. There is one more part which for some strange and inexplicable reason has been taken out of this book here, the book that I showed you before, the revised GRE, the book that I showed you in the very beginning, the revised GRE. But as I told you, the problem that we are doing is the exact same problem that appeared in the 10th edition of the book, and there is one more part, part C, in the 10th edition, and I'm going to do that part anyway, even though it does no longer exist in the new book, part C. I erased the page number, but as I told you, it was on page number 79. Page 79 of 10th edition. So let's do that, just for the hell of it. Do you understand? As the adage goes, one can never have too much fun when one is solving a math problem. And that adage, of course, prevails in the geek land, you understand? Not the normal land. Part C. The question is this: prepared photochemicals represent what degree of the pie chart? And that's all it is. That's all. Very simple, very straightforward. Prepared photochemicals would represent, if on a pie chart, it will represent what degree of the pie chart. For example, if something, for example, here, is there anything that, there you go, office copier, we are told, office copiers, we are told, is 25% of the whole amount, isn't it? So if it's 25% of the whole amount, it should show up as exactly 90 degrees. 1/4 of the circle. And if you look at the chart closely, even though the copier part is a little tilted there, if you look at closely, it is exactly 90% of the whole chart. The question is, what will be the degree measurement of the category that represents prepared photochemicals? Let's look at prepared photochemical. Prepared photochemical is 7%. 7%. The question simply now is, 7% of 360 is what? For example, if something is 10%, if something represents 10% of the whole amount, 10% in the circle will show up as 36 degrees, because there are 360 degrees, and therefore 1/10 of a circle will be 36 degrees. So this is 7%, it's going to be a little bit less than 36 degrees, obviously. Let's find out. 7% means over 100, of means times, and 360. Is means what, and there is your unknown. That's it. Divide top and bottom by 10, and then we have 7 times 36 times over 10. Let's see what we can do here. Let's do it on the top here, or we can continue here. Let's divide top and bottom by 2, so this becomes 5, and this becomes, or rather, let's divide top and bottom by 5. If you divide top and bottom by 5, there are 2 5s and a 10. How many 5s in a 36? 36 has 7 5s. Even though 7 5s are 35, and this is 36, I'm taking liberties, I'm approximating. So that's it, we're done. 7 times 7 is 49, so x represents 49 degrees. That does not sound right at all, because as I told you before, as I just got done explaining to you, that if something were 10% of the total amount, 10% of circle would represent 36 degrees. This bloody thing is only 7%, and yet we're coming up with 49. Something has gone wrong. 7 times 7 is 49. Divided by 2. X is 49 over 2, which is about 25 degrees. Which makes far more sense, because as we already said before, that the answer is going to be a little bit less than 36 degrees, because 36 degrees is 1/10 of a circle, and therefore 10% of something, 10% of the whole circle would have been 10% of the whole circle would have been 36 degrees. This represents the 7% of whole circle. 7% of whole circle would have to be something less than 36 degrees, and it turns out to be 25 degrees. That was it. I will see you tomorrow, where we'll do the problems that you see on the following page, which has to do with what is known as a scatter plot, and we'll also do the problem that you see on the page after that, which has to do with Venn diagram. So tomorrow we'll do 4.6.3 and 4.6.4. Those are the last two problems before the exercises begin, and the problems that you see in the exercises they have already been done. They've already been done. So I'll see you tomorrow. Okay? Bye now.